So once again, welcome back to the last session of this P block element 2. In this content, we are going to look into the group 18 elements. See, the group 18 family includes the inert gas, which otherwise called as a noble gas, otherwise it called as a rare gas. Okay, the elements includes are helium, neon, argon, krypton, xenon, radon. So it is all quite familiar to you all. And group 18 also include organism. Okay, but that has not been dealt as much. We are dealing with the rest of the elements of this group 18. Okay, this occurrence, if you look into it, it exists in the atmosphere and in the form of a gas. Regarding its physical state, at the room temperature, it exists in the form of a gas, atomic number, atomic mass, density, melting point, boiling point, everything increases from helium to the radon. No doubt in that. The next one is the very first ionization energy definitely will decreases as we move from helium to the radon. As the size of an atom increases, the nuclear attraction decreases, the ionization energy should obviously decrease. The next one is noble gas. See, among the elements of the periodic table, noble gas shows the highest or the largest ionization energy because it is completely stable, attaining the octet electronic configuration in the valence shell. So it is 8 electron in the outermost shell, it's more stable, completely stable. So in that scenario, it is very difficult to remove an electron, so it requires the more amount of an energy if you look into the rest of the elements in the same period. The next one is, it is extremely stable, no doubt in that, and very less tendency to gain an electron, lose an electron, because it is already stable. Under certain condition in which its property is being altered, it cannot gain electron or lose electron. Only in such scenario it can gain electron or lose electron. Then regarding isotopes is neon, argon, krypton, xenon, or this helium. All these elements exist in its own elemental form, but radon alone exists as 3 isotopes, which is mass number 210, 220, 222. These 3 one. And regarding its electronic configuration, it's very known to us. Starts with the helium is known 1s2. Then from the neon to the radon, enclosing the noble gases, helium, neon, argon, krypton, xenon, radon. Then followed by it is the valence electronic configuration is ns2 np6. So it is 2s2 2p6, 3s2 3p6, 4s2 4p6, 5s2 5p6, 6s2 6p6. Before 4s 3d10 comes. Before 5s 4d10 comes. Before 6s 4f and 5d comes. So it is very clear. Then regarding its properties, it is a monoatomic, no doubt in that, because bond order will be 0. We have studied in molecular orbital theory itself. No color, no taste, highly inflammable, which cannot start to burn. Okay, that's what highly non-inflammable. Not inflammable, non-inflammable. Then highly unreactive, say it's stable, it will not react so easily. Then since it is present in the p block elements and present at the extreme right of the periodic table, it must be a non-metal. Okay. Then chemical property. Among the various elements of the group 18, only krypton and xenon shows some chemical reactivity here. Xenon reacts with the fluorine at different conditions, giving rise to the different products. Very firstly, xenon reacts with the fluorine in the presence of a nickel at 400 degrees Celsius. You will be getting xenon difluoride. The same condition along with the acetone, you will be getting xenon tetrafluoride. The same condition along with 200 atmospheric pressure, you will be getting xenon hexafluoride. Let's look into it. See, xenon reacts with the fluorine in this condition to form xenon fluoride. Then in the presence of a nickel acetone at 400 degrees Celsius, xenon reacts with fluorine to form xenon tetrafluoride. Then similarly, in this condition at 2 atmospheric pressure, it forms xenon reacts with 3 moles of the fluorine and forms xenon hexafluoride. Okay, so this is the reaction. Then xenon hexafluoride that has been formed is capable of reacting with silica and gives rise to the different products. The whole reaction has to be carried out in the sealed quartz vessel and by maintaining a temperature of 50 degrees Celsius. See, the xenon hexafluoride reacts with silica or silicon dioxide. It can be named in any way. It forms xenon oxide tetrafluoride, XeOF4, then silicon tetrafluoride, SiF4. So to balance with here, fluorine is 6 there. There it is 8. So we cannot balance it as such. So what's the way that we can do? If I make it as 2 here, xenon becomes 2. So if I make it as 2 here, fluorine is balanced, xenon is balanced, oxygen is balanced, silicon is balanced. The equation is balanced. Okay. So this is how we need to balance. Reacts in the ratio of 2:1. Then followed by the consecutive reaction here. The xenon dioxide difluoride reacts with silica and forms xenon trioxide here. See, xenon dioxide difluoride XeO2F2. The previous one is oxytetrafluoride. This is xenon difluoride. Reacts with silica and forms xenon trioxide XeO3, then silicon tetrafluoride SiF4. So to balance with, fluorine is 4 on the right side, so here it is 2, I'll make it as 2. So xenon is 2, I'll make it as 2 here. Then silicon 1, no problem. Oxygen 4 plus 2, 6. Fluorine is 4, everything is balanced. Then xenon hexafluoride XeF6 reacts with the water vapor, which is water, to form xenon trioxide XeO3 plus hydrofluoric acid. Hydrofluoric acid is a weak acid. Okay. Then hydrogen is fluorine here is 6, so I'll make it as 6 here. Then oxygen is 3, so I'll make it as 3. Xenon is 1, hydrogen is 6, everything is balanced. Then xenon hexafluoride reacts with sodium hydroxide to form sodium perxenate Na4 XeO6. Okay. Then followed by xenon, then oxygen, then sodium fluoride, then water. Okay. So to balance with, assume that this reaction takes place in the ratio of 1:8, so I'll make it as 2:16. So sodium becomes, first let me balance with the fluorine. Fluorine is 12. So if I make it as 12, sodium on the right side it becomes 16, left side also it becomes 16, no doubt in that. Then xenon, left side it is 2, right side it is 2. Oxygen, left side it is 16, there it is, okay, before the hydrogen, 16 hydrogen in the left side. So in order to make it 16 hydrogen, I will make 8 here, so the hydrogen becomes 16. Oxygen now, 16 on the left side, right side, 8 plus 6 is 14, 14 plus 2 is 16. Equation is balanced. So reaction takes place in the ratio of 1:2, that's what 2:16 ratio, 1:8. Okay, the next one. The next reaction actually includes the informative content. See, xenon is capable of reacting with a coordination complex like platinum hexafluoride and form xenon hexafluoroplatinate. It's an orange yellow solid and it is insoluble in the carbon tetrachloride, which means in the bonding more ionic character is there. That's why it is not able to dissolve in the non-polar solvents. Then xenon difluoride forms an addition compounds with antimonide pentafluoride and tantalum pentafluoride. So xenon XeF2 with 2SbF5 or 2TaF5. So in such it has been formed. Then xenon hexafluoride is capable of reacting with boron or other alkali metals to form an addition products. Boron compound is boron trifluoride, which is an electron deficient. So HCF6 forms a bond with BF3 through a coordinate bond. Then XeF6 can also form a bond with the metal fluorides. Okay, MM. Then xenon dichloride, there are no exact reaction that has been found, but the possibility of existence has been found. So this is regarding xenon dichloride. Then krypton will react with the fluorine at 180 degrees cause an electric discharge. An electric discharge alone should generate a temperature of 183 degrees Celsius. Otherwise, a gas can be irradiated with the antimony pentafluoride to form krypton difluoride along with the addition product 2SbF3 antimony trifluoride. So this is an informative content. The next one, last part of the content is structures of compounds of the xenon. See, this xenon compounds actually includes xenon fluoride, xenon tetrafluoride, xenon hexafluoride, then followed by XeOF2, then followed by XeO3, xenon trioxide. Structurally, see, what you need to remember is, it is XeF2, XeF4, XeF6, XeOF2, XeOF4, XeO3. So this is all. So the bond pairs is bond pairs and the lone pairs. So how do you have these things in mind? See, regarding hybridization, if you look into there, xenon here, xenon forms difluoride, XeF2. The valence electronic configuration, valence shell contains 8 electrons in the xenon. So 2 has been utilized for the bonding, remaining 6 will be there. So 6 is there. So the molecule will exist in the linear shape, and the hybridization is sp3d. because 5 orbitals are involved in the hybridization, 2 for the bond pairs and 3 for the lone pairs. So the hybridization is sp3. The next one, so structure is linear, it's quite clear. XeF4. If you look into the XeF4, XeF, so this is your square planar structure. Okay. Then regarding this lone pairs and all, out of valence electron, 4 is utilized for the bond pairs. Then the remaining 4 electrons are remain as a lone pair above the plane and below the plane. So therefore, it gives in the structure of the square planar. Here the hybridization is 4 for the bonding and 2 for the lone pairs. So it is sp3d2. Okay, sp3d2. The structure is square planar. Okay, so now from this it is very clear. 4 bond pairs and 2 lone pairs. So that is what? 4 bond pairs and 2 lone pairs. The next one. Next one is XeF6. XeF6 is distorted octahedron. XeF. Some distortion is there. Okay. First square planar XeF. Then distortions are there. F. So if you connect it with the help of the other, you will represent it. It is, so it is a square bipyramidal structure you will be getting. Okay, you will be getting what? Square bipyramidal structure. So this is what octahedron, but this is not an exact octahedron. Some distortions are there. So that's why it is distorted octahedron. So totally out of 8 valence electron, 6 are used for the bonding. Then 2 electrons are left as a lone pairs. So it is 6 bonding pairs of an electron and 1 lone pairs of an electron. So that's all regarding this. Okay. Then the structure is distorted octahedron structure. The next one is XeOF2. XeOF2 structure includes XeOFF. So this is what the structure. So the lone pairs out of 8, 4 is used for bonding and the 2 will be left as a lone pair. So it exists in the form of a T shape. Okay. See, the pi bond is formed by the overlapping of an unhybridized orbital. Leaving out that, 3 has been used for the formation of the bonding pairs of an electron. Then 2 is allocated for the lone pairs. So it is 3 plus 2, 5. So hybridization can be sp3d. Okay. It depends on the number of orbitals overlapping. The hybridization, hybridized orbitals will come. Okay, so that is regarding that. Next one, XeOF4. XeOF4, the structure is square pyramidal structure. So it is XeOF. So it's a square. If you connect this oxygen, you will get a pyramid. So it's a square pyramidal structure. Okay. Then out of this 5 electrons are used to accommodate 6 electrons are used for the bonding. Then the remaining 2 electrons will exist as a lone pairs here. But the hybridization involves sp3d. Okay, sp3d2. Okay, because one is for the lone pair. sp3d2. One is for the lone pair. sp3d2. The pi bond alone will be formed by the overlapping of an unhybridized orbital. Next one. XeO3. XeO3 will get a structure of a pyramidal structure. O. Okay, then one lone pairs will be present here. So it gets a pyramidal structure. So the hybridization is sp3 hybridization because the 3 pi bonding is formed by the unhybridized p orbital. So it's very clear. So these are all the structures of this inert gases, the compounds of the inert gases. Then the last part uses. You can see through the textbook. The only one peculiar thing is helium along with the oxygen is used to treat the harmful, painful condition called as bends, which means the one who is undergoing the deep sea divers, they in their oxygen cylinder it will be present along with the helium also. So helium along with the oxygen is used to treat the painful condition for the deep sea divers. It is called as bends. Then argon is used for the maintaining inert atmosphere in the electrical lamps, okay, bulbs, okay, to create inert atmosphere. Then krypton, xenon, krypton, neon are used for the fluorescent bulbs. So this is regarding this. Okay. So radon is widely used to treat for the cancer treatment also. So that is the Benz is the only uses that has been given something new, which is not aware of it. Then rest of the uses are quite similar. You can go through it. Okay. So we have done with this group 18. So from the beginning we have started with the group 15. In the group 15 we saw what is nitrogen and its physical and chemical properties, ammonia, nitric acid, structures of oxides of nitrogen, then followed by the phosphorus. Phosphorus we have seen allotropes of the phosphorus. Then phosphorus trichloride, phosphorus pentachloride, oxides of the oxides of the phosphorus, oxoacids of the phosphorus we have seen. Then in the halogen family, chlorine we have seen, HCl we have seen. Then the intrahalogen compounds we have seen, trends in physical and the chemical properties we have seen. Then in the group 16, oxygen we have seen, sulfur dioxide we have seen. So all these things, sulfuric acid we have seen as a major content. So these are all the contents regarding this P block elements too. Okay. The only thing is you have to work on with the balancing the equation, and some stoichiometry of the particular reaction has to be kept in the mind to avoid utilizing more time during the examination. So that's it regarding this. If you need to post something much which is needed to you, you can post the things in the comment box below so that I would be able to note it and get it done to you. Okay. So see you all with the next session. Probably we have an ideas of coming up with the word problems, how to solve with the word problems and solving certain word problems from those unit 11, 12, 13 hydroxy compounds and ethers, carbonyl compound, carboxylic acid, organic nitrogen compound. See you all in the next session with some other content. Thank you.